Hey, everybody. So we are getting into 14.1 today, looking at what's called the law of sines. And specifically, we'll be looking for missing side lengths today. All right. So I guess here's the idea on this lesson. And it kind of spells it out right here. It says the trigonometric ratios you have seen so far in this chapter, referring to chapter 13, can be used to find angles and side measures in right triangles. Okay, if you guys remember when we were using, tangent, sine, cosine, we were always finding missing sides and angles of right triangles. Okay, they had to be right triangles. Okay, today it says you can use the law of sines to find angle and side measures in any triangle. Okay, we no longer need right triangles when we're using the law of sine. Okay, so yeah, let's just kind of break down what it is. All right, so here is the law of sines. This proportion right here. Okay, we have side length A over sine of angle A equals B over sine B. All right, so go ahead, take a second and copy this, and then I'll break down how it works. All right, so here's the idea. When you go to make your ratios, you're always going to put your side length up top and then the angle opposite that side length on the bottom. Okay, and specifically sine of that angle opposite. So if we're taking a look at this triangle over here, I would start with this side length, A, okay, and then I would put it over sine of angle A, that angle opposite that side length. Okay, and it's the same idea. When I go to choose another side length, say I chose this side length B, I would need to put it over sine of the angle opposite that side length, which would be this angle. Okay, so setting up the proportion is, the big part here. After we set this thing up, we're just going to be cross multiplying and, solving like we've done in the past. And a lot of this will be taken care of with the calculator. So it's not too shabby. It makes more sense when you see an example. So yeah, let's jump into it. Okay, so take a second, copy this example, and we'll look it over. All right, so find AB, segment AB. All right, so here is the side length AB. This is what we're looking for. That's going to be what we're looking, that's our variable. Okay, from here, let me just point out a couple things. First of all, this is not a right triangle. There is no 90-degree angle on this triangle. There's a 91-degree angle. But yeah, this is not a right triangle. Well, I guess we can't use our normal trig on this. We're using law of sines on this. All right, so let's kind of break down. When I go to make my first ratio, if I'm finding a missing side like we're doing today, I always start with that side length on the top. Whatever the one I'm looking for, that's what I start with. Okay, so on this problem, we're looking for this side length. We called it X, so that's going to go in the top of my ratio. Okay, here's the big thing. On the bottom of my ratio, I'm going to put sine of the angle opposite this side length that I'm using. If I'm using this side length, the angle opposite this side is 58 degrees. All right, so 58 degrees needs to go on the bottom. Okay, and I'm going to set that equal to another side and its opposite angle for my other ratio. All right, so I'm taking a look. I'm noticing, all right, I also have this side length right here. So 33. Okay, remember the side lengths always go on the top of the ratio. Okay, on the bottom of it, sine of the angle opposite this side length, if that's my side length, opposite it is this 91-degree angle. Okay, so that's setting up these problems. Again, I think that's the most important part. After you get to this step, we're going to cross multiply like we were doing in the past with what was that, similar triangles? All right, so when I go to cross multiply, I like to start with the one that has my variable. So I'm going to start with x times sine 91. All right, and I'm just going to write it out just like that. So x times sine 91 degrees. Okay, and I'm going to set that equal to my other cross multiplication, 33 times sine 58. All right, just a couple small things. When you go to write out the multiplication, I would always multiply, the sine times, the side times sine, 58. Okay, I wouldn't flip these two spots because typing into the calculator, this works better. Okay, so what are we doing here? All right, we're trying to find x, right? Well, over here, I notice to get x by itself, we got to get rid of sine 91. Okay, it's being multiplied by x. So to undo it, we're going to divide. So divide by sine 91. Right? Whatever we do to one side, we have to do to the other. Okay, so these are canceling. We're getting x by itself. Over on the right, this is what we type into our calculator. All right, so grab your calculator and do this along with me. So we're starting with 33 times sine 58. So I'm going to bring up mine here. Oh, here's me. Goodbye. Okay, so 33 times sine 58. All right, and then here's the thing in your calculator. Make sure you close the parentheses. Okay, close the parentheses. Mine does it already, but your calculator might not. Close the parentheses and then divided by, all right, let's see, what was I dividing by? Sine 91. So sine 91. Okay, and you should be getting a 27.98 in your calculator. We're going to round to one decimal place like we normally do. Here's the thing on this problem. That 9 is being rounded up, right? So that then means this 27 is rounding up to a 28. So we'd actually write this as 28.0 if we were rounding to the one decimal place. Okay, so yeah, 28.0. There's no units here, so we're good. And it's our answer. All right, just something I'll always say, make sure your answer makes sense in the context of your triangle. The long side of my triangle is 33. Does it make sense for this side to be 28? Yeah, that makes a lot of sense. Okay, cool. Let's try another. Go ahead and copy this. We'll try it out. Okay, so first thing, what are they asking? Find side BC. So here's BC. That's my variable. Okay, I'm going to go and make my first ratio just so we're all on the same page. Here is, my little formula I'm using. My first ratio is the side length I'm looking for over sine of the angle opposite that side length. All right, so the side length I'm looking for on this one is x. That goes up top over sine of the angle opposite this side, which is 94. Okay, and I'm going to set it equal to another side over sine of the angle opposite that side. All right, I know this side right here, 29, over sine of the angle opposite this side, which is 38. Okay, once you get these pieces in the right spots, cross multiplying, solving, it's not too bad. It looks weird, but it's all in the calculator basically. So yeah, let's start with this. So x times sine 38. Okay, setting that equal to my other cross multiplication, 9 times sine 94. 29 times sine 94. Okay, cool. And then basically last step, solving for x, get rid of sine 38. It's being multiplied, so we divide by sine 38. Okay. If we did it to the left, we got to do it to the right. All right, so yeah, these are gone. I got x on the left, over on the right. Again, this is what you type into your calculator. All right, this is maybe the big thing, making sure you're actually typing this in correctly. So do this with me and make sure it's looking good. So let's start with 29 times sine 94. 29 times sine 94. Make sure to close your parentheses, or if I'm on my thing, I'm making sure I'm clicking outside the parentheses. Okay, so, and then divided by, let me remind myself, sine 38. Okay, so let's see. Divided by, divided by sine 38. Okay, and I'm getting 28.92. On this one, it looks like this 9 doesn't round up, so this is just 28.9. All right, and yeah, interesting. Let me double check this on my other calculator because I'm looking at my answer. Here's what I'm just thinking: 28.9. This looks like it should be the long side. This side's 29. I wouldn't expect this side to be shorter. So I'm making sure I actually type this in correctly. 29 times sine 94 divided by sine 38. Interesting. In my calculator that I have sitting on my desk, I'm getting 46.98. Okay, so 46.98. That 9 would then round up. This rounds up to 47.0. Okay, so I'm sorry. That's what you should be getting. I'm really kind of not sure why this last problem did that to me. I just want to try this again. Sorry, I know this is a video, but it's a learning experience. 29 times sine 94, clicking out of it, divided by y. I want to do that. Oh man, what is going on here? Divided by, and then what was it? Hold up. Sine 38. All right, sine 38. And it's giving me the right answer. So weird. There's something weird about this this website. I guess if I click in and out of it, it doesn't give me the right answer potentially. Okay, so that's what we should get on this one. I just want to check this one real quick. So bear with me on the videos. 33 times sine 58 divided by sine 91. Okay, this one was actually right. I have no idea what happened on the last one. Maybe I typed it in wrong. Okay, you probably know better than me. Okay, so I'm gonna have you guys try one of these on your own. Go ahead and set up the whole thing, type it in your calculator correctly, and then we'll see how it goes. Okay, cool. So let's see. Side length AB is what we're looking for. There's X. So there's my first ratio I'm gonna make. Side length over sine of the angle opposite that side length, 58 degrees. And then do the same thing. The other side length that we know, so 15 over sine of the angle opposite that, so sine 26. Okay, check out your proportion. Make sure it looks a lot like mine or just like mine. Cool, so let's try it out. So we got x times sine 26 equals 15 times sine 58. Okay, and then solving for x is being multiplied by sine 26, so I'm going to divide by sine 26 on both sides. All right, so yeah, those are gone. Got x equals over here. Let's see. I'm going to just do this in my calculator because I don't trust that website anymore. 15 times sine 58, close parentheses, divided by sine 26. If you're doing this correctly, you should be getting 29.01. So that means that 0 doesn't round up, so 29.0. All right, by the way, we're getting a lot of point zeros on these problems. That's just a coincidence. That does not always happen. That's just the way these problems were made to work out. Okay, so yeah, that's the process. We have a couple more to look at that just throw a little wrinkle. So let's look at another example. Go ahead and copy this and we'll try it together. Okay, so this one's asking for AC. So here's my side length. All right, so I can go ahead and make my first ratio, side length x over the sine of the angle opposite that side length, 52. Okay, so far, nothing different. When I go to make my other ratio, I'm going to use, this other side length I know, 28, over the sine of the angle opposite that side length. Be careful. The angle opposite this side length is not 66. It is this angle. Okay, which they didn't give us. But we know how to find missing angles of a triangle if we have the other two. Remember, this is, the classic 180 subtracting these two angles. Okay, so just, worth showing in your notes. We're taking 180, we're subtracting 66 and 52, and we're getting this missing angle. So 180, let's see, minus 66 minus 52 looks like 62 degrees. Okay, so in your notes, show yourself that thing is 62, and that's why up here, yeah, we're using that 62 degree angle. Okay, so that's the only difference on these problems. They're not giving us some of the opposite angles from the side lengths we're using, but we can find them. Okay, so yeah, that's the process. Let's go ahead and cross multiply. So x times sine 62 equals 28 times sine 52. Okay, and if I'm going too fast for you, feel free to pause the video and catch up with me. Okay, so there it is. And you're getting hopefully the process here. Last thing, getting rid of sine 62. It's being multiplied by x. So we'll get rid of it by dividing. And we got to do it to both sides. So they're gone. I got x on the left, on the right. Okay, take a second, type that into your calculator, and then let's see if we get the same answer. 28 times sine 52, close parentheses. Make sure, man, it might be worth in your notes kind of just showing yourself parentheses around this. Yeah, or maybe going back to one of the first examples and just showing that parentheses needs to be closed and then divided by sine 62. It's really easy to mess these up in the calculator, as you guys saw earlier. So yeah, 24.98 is what we're getting. Okay, and that 9 is being rounded up, so that then rounds this 24 up to a 25. Okay, so another one where it's getting rounded up, 25.0. All right, cool. So I want you guys to try out one of these on your own, and that will be that. Okay, go ahead and draw this one out. All right, so let's see. BC is what we're looking for. There's my side. Let's go ahead and make our first ratio with this side and its opposite angle. So x over sine 38 degrees. And our next ratio, we're going to use this other side we know over the angle opposite to that side, but you guys can see on this one, we don't know. Okay, so I'm going to start writing this out though. So 26 over sine, and I need to find this angle. So again, I'm just taking 180 in my calculator, subtracting these other two, 98, 38, and let's see what happens. 98 minus 38 looks like we're getting 44. So there is the measure of that angle, and that's the one we want to use. Cool. So what happens? So we got x times sine 44. Sure, I'll use green. And let's just switch up these colors, right? Okay, so x times sine 44 equals 26 times sine 38. All right, and yeah, solving for x, get rid of sine 44 by dividing both sides. All right, so we got x equals 26 times sine 38, and then just to make it obvious, I'm putting big, thick parentheses right there to remind myself, close them. So 26 times sine 38, close parentheses, divided by sine 44. 23.04, so that 0 is not rounded up, 23.0. All right. I forgot on the last couple problems, but does that make sense? This being 23, that being 26. Yeah, they almost look like they're about the same length. On my last problem, this was 25, this one's 28. Yeah, this is working. Okay, so yeah, that's using law of sine. It's really not too difficult. It might be even easier than the trig stuff. But yeah, you can use this on any non-right triangle. So that's the good thing about it. It's probably more practical than the other trig stuff. Okay, cool. Thanks, guys. Bye.